What is acceleration? Acceleration is defined as the change in velocity divided by the time it takes to make the change. Mathematically, A is delta V over delta T, or the final velocity minus initial velocity over final time minus initial time. If we started from time equals 0, we can simplify our formula. I will be focusing on constant acceleration in this video, also known as uniformly accelerated motion. Let's say we have a car with an average acceleration of 10 meters per second squared. By the way, that is the SI unit of acceleration because velocity is meter per second and time is in seconds. So acceleration is meters per second or second squared. So what does 10 meters per second squared mean? Let's say our car is traveling along a straight line. Let's assume that our car started from rest and we have the means to check our car's velocity every second. So, after 1 second, our car's velocity becomes 10 meters per second, which is originally at rest. After another second, our car now is traveling with a velocity of 20 meters per second. After another second, we have a velocity of 30 meters per second. After another second, the velocity changes to 40 meters per second. And after another second, it reaches 50 meters per second. Probably you get the idea here. The difference between these velocities after every second is 10. That's why the acceleration is 10 meters per second squared. Alternately, if you choose 2 points here, let's say the first and second for example, and plug those values in our acceleration formula, you will get 10 meters per second squared as well. The most confusing aspect of solving acceleration is the direction. Let's say we have 4 cars here. The first 2 cars are traveling to the right, which I assume the positive direction, making velocity positive as well. Now, if the first car is speeding up, then the direction of the acceleration is to the right as well. If it slows down, then the direction would be to the left or negative. I think many understand that very well, but look at the third and the fourth car. Both of them are traveling to the left, and if we assume that left is negative, then both of their velocities will be negative. Now, what if the third car is speeding up? In that case, the acceleration will be negative. If the car is slowing down, just like the fourth car, then the acceleration is positive. To sum it up, we can say that if an object is speeding up, velocity and acceleration have the same signs. On the other hand, they will have opposite sign if the object is slowing down. You can also relate the direction of the acceleration from the direction of the object's displacement, since velocity has the same direction to its displacement. Bear in mind that you will see a lot of rules to follow later on regarding this, specifically when we introduce force in the equation. But for now, these are the things that we need. The most important note to remember is the sign or direction of acceleration alone is not enough to say that the object is speeding up or slowing down. Since our formula for average acceleration is equal to the final velocity minus the initial velocity over the total time, we can actually find the final velocity by adding the initial velocity and the product of the average acceleration and time if acceleration is given. Also, if we include displacement in our equation, we can find the final position of the object by getting the sum of its initial position, the product of its initial velocity and the time, and half the product of the acceleration and the square of the time. If our initial position is 0, then we can simplify our formula. Another formula that we need is the square of the final velocity is equal to the sum of the square of the initial velocity and twice the product of the acceleration and the displacement since the initial time. Take note that you can use all of these when dealing with uniformly accelerated motion or constant acceleration. Let's try this one. You are driving a car at a constant velocity of 25 meters per second along a straight road when you see a car in front of you. You apply the brake to avoid collision, so your car slows down steadily and comes to a stop after 0.45 seconds. What is the displacement of the car before it stops? The first step that you need to do is to draw a diagram of the situation. So we have a car in a straight road with an initial velocity of 25 meters per second. You apply the brake, bringing the car to a stop, so your final velocity will be 0. And it took you 0.45 seconds to bring the car to stop, so you traveled a certain distance within that time, which is the one that we are looking for. We choose right to be our positive, therefore we would expect a positive displacement, and since the car slows down, traveling to the right, our acceleration will be negative in this case. From the formulas that I have mentioned, we can actually use both of these formulas to solve for the displacement. But we can't solve for the displacement without solving for the acceleration first. Since acceleration is equal to the final velocity minus the initial velocity over time, the car's acceleration will be negative 55.56 meters per second squared. Now plugging that to our first equation right here, we will get a displacement of 5.62 meters. Now if we use the other formula, you will get the same thing. And by the way, our displacement is positive just like what we predicted. You will be meeting a lot of problems like this in your study of physics, and practicing will always help. So keep solving and see you again next time.